Hi everyone, today we are going to be talking about domain and range. So domain is any x value that works for the function, and the range is any y value that works for the function. And you might think that you can plug in any value of x and it would work, but actually this is not true because some values of x do not work. And there are two things you have to look out for to see if the x value does not work. And the first thing is to make sure that the denominator doesn't equal 0. Because if the denominator equals 0, then that means that you're dividing by 0, and you're not allowed to divide numbers by 0. The second rule is that there's a negative number in a square root. Because you can't have a negative number in a square root because that would be an imaginary number. So values of x that make a negative value in a square root would not work and would not be part of the domain. So domain and range can be written in several different ways, and the first way is just in letters, normal letters. So for example, you can say all real numbers, and that could be your answer to a domain or range question. Or you can also write it in an inequality. So for example, if you have the number, if you're trying to look for the domain and you want to say that the domain is anywhere between -4 and 4, then you could say -4 is less than x less than 4. But if it also includes the number -4 and 4, then you could write less than or equal to x less than or equal to 4. And the last way you can write domain and range is with brackets or parentheses. So when you have a open bracket, or if you have a just normal parenthesis and write -4, comma 4, this means the same thing as the inequality above, and it just means any number between -4 and 4, but not including -4 and 4. But if you want to include those two numbers like this inequality, then you're going to do a bracket, -4, comma 4. So the first problem we have here gives us a graph and it asks for the domain and the range. So the domain is from -4 to 4, because the graph goes from -4 all the way to 4. So we can either write that as an inequality, -4 is less than or equal to x, which is less than or equal to 4, and we write less than or equal to, and this graph should have little dots here, closed dots, to indicate that it includes those points. And we can also write the domain as a closed bracket or just bracket, -4, comma 4. And the range goes from -2 to +2, because the graph covers the y values from -2 to 2. And we can write that as -2 is less than or equal to y, which is less than or equal to 2, or we can write that as in bracket form. Okay. Next question. It also gives us a graph and asks for the domain and range. So the domain starts at 0 right here. And this graph, it's cut off because of the boundaries of the graph, but we know that this graph keeps going on all the way to infinity and beyond. So the domain is any number that is greater than or equal to x, or 0, because it starts at 0 and the graph continues on forever in the towards the right in the x direction. And we can also write this as a closed bracket, 0, comma infinity, because it goes on forever. And when we write infinity, we have to write parentheses instead of this bracket, because the graph doesn't necessarily touch infinity, and because infinity is not really a number. So yeah. And the range. The range, we know this graph goes up forever and it goes down forever. So the range is also infinity, and we can write that as all real numbers, or we can write that as a parenthesis, -infinity, comma infinity. So now we have a few functions here, and it asks us to find the domain and range. And what I would recommend when trying to solve these problems is to visualize them in your head and visualize the graph. So the first, we have function of x equals 2x plus 4, and when we draw that as a graph, it's going to be a line sort of like this. So we know that the line goes on forever and ever in this diagonal direction. So that means the domain keeps going on right and left, so it's infinity, and so does the range. So the domain is -infinity to infinity, and so is the range. So now we have f of x equals 2 over x minus 2. And when we think of this graph, we know the graph of 1 over x is going to look something like this. And since this is x minus 2, we're going to shift that 2 to the right. So it's going to look something like this. And yeah, it's going to look something like that. And so when we think of the domain, we know that the red graph, which is this 2 over x minus, my estimate of 2 over x minus 2, we know that it's going to keep going to the right, and it's going to keep going to the left. But then it has like this vertical asymptote in the middle right here, which means it doesn't touch that x value. So when we think about this, we have to go back to our original rule we had here. So the denominator cannot be 0. We have to remember that rule for the domain. So the denominator cannot be 0. And what value of x makes the denominator 0? Well, it's x equals 2. And when we have 2 over 0, we can't do that because we can't divide numbers by 0. So the domain would be any number except 2. So the range, and this means any number, all real numbers except 2. So it means it can go on to negative infinity, and all the way to infinity, but it just does not touch x equals 2. And the range, if you look at the graph, it goes down forever and it goes up forever, except there is a horizontal asymptote on the x-axis right here. And this makes sense because if we look at this original function right here, we know that no matter what number of x we plug in, we can never get 0. So the range is all values except 0. And so the last question says, function of x equals the square root of x minus 2. And this graph will sort of be something like this. So the domain, we know that this graph goes on forever here. It just doesn't go anywhere to the left of this point right here. And if we remember the previous rules on this page, it says there cannot never be a negative number in a square root. And here, if we plug in any number that's 2 or greater, we're going to get positive numbers. But if we plug in any number less than 2, for example 0 or 1, we're going to get a negative inside the square root. So that means the domain is any number greater than or equal to 2. As if we plug in any number less than 2, we're going to get a negative square root. That's why it's important to remember the rule that we had on the first page. So then the range. The range, as we can see in this picture, the graph goes all the way up because this graph just keeps moving there and it will keep moving up, except the graph will never reach this bottom region right here. It'll never go down. And this is the x-axis, so it's 0. So the range is anything that is greater than or equal to 0, because the graph, the picture of the graph that we visualized, can never go below the x-axis, and it always has to go. It touches 0, and it can go up. So it's any number that is greater than or equal to 0. And we can also write this as a closed bracket 2 comma infinity, and 0 comma infinity. We can write it both ways, but they mean the same thing. Okay, thank you for watching.